Macros. So I know macros are what Nim is known for a little bit, and I expect them to be a little bit hard to work with, but not as hard as in other languages. So Nim's syntax is incredibly versatile, and macros can be used to rewrite the abstract syntax tree of a program. The general process for writing a macro consists of 2 steps that are repeated until the desired results are achieved. So dump and examine the AST, abstract syntax tree. Modify the abstract syntax tree to match the desired shape. Okay, so I like it. That means that compiler basically gives us the syntax tree, which is basically how compiler understands the language, after it parsed it, and then we basically can modify it. Okay, the example shown here describes how to create new class syntax in Nim purely through a library. Ooh, new class syntax. This is the code that we currently must write to use OOP in Nim. So type animal and ref object with object, we have that. We have this whole vocalize with base, and then we have the dog and cat. We already went through that today, okay? All these type definitions and self-t parameters are repetitive. So it'd be good to write a macro to mask them. Something like this would be nice. Look at that. So instead of doing type animal and we have this ref object of root, whatever, we can do class animal of root object. Very much. I like it. And then we just give it those 2, and we have method vocalize and method humans, right? And the self is just injected, right? Just like in other languages, you don't have to reference self. It's usually injected for you. And then we have class dog of animal, and we just have the same thing. We don't need to specify some other stuff. Okay, we don't even need to say that these are base. Okay. And class cat of animal with meow. To get that nice notation, we can use a macro, and that's some code. Mostly comments. So let's look at that, because this is really nice. Too bad it's not by default in the language, but I guess doesn't have to be. If you want to have something like that, you just write yourself a macro and you extend your language. Okay, import macros. Okay, and we have new keyword macro. We call it class. I guess we make it usable by other modules. We have head, body, and they are both untyped. So head, I guess will be this, while body will be that. So the macro is immediate, since all these parameters are untyped. Okay, I think I read a little bit about it somewhere, and it was basically that when you would specify that these are typed, the compiler would need to first analyze all this and maybe all that and figure out what is, type inference, all that stuff. And then what you would get is a little bit more complex syntax tree that has a lot more in there because of that. There's a lot more information, therefore it's more difficult to work with because, it's way more specific. But here we have it untyped. This means it doesn't resolve identifiers passed to it. Yes, so basically things that are passed to it are not going through the compiler at all. The compiler doesn't check if this is right or not. It's just, you just pass it on and it will be happy with it. Okay, I wonder how that impacts a syntax highlighting. Interesting. Or some other checks that it potentially could do. Alrighty, so in that macro, we define variable, type name, and base name, and we say that both are a nim node. Flag, if object should be exported. So as exported, and we say bool. Okay, so we don't have values for those yet. So if head.kind is nnk infix and indentation head 0 off. Okay, head is expression. Type name of base class. Yes, so I was right. This of that. Okay, so we checked if the kind is of nnk infix, and Yanakali says that nnk stands for nim node kind. That's very helpful. Okay, I like that. Simple prefix to just call it that way. Okay, and looks like this is just something defined on the macro. Yes, it's a prefix like old style C. Yes. Okay, so we have infix and the EQ ident. So some kind of identifier. So this is basically, we have the situation where, this is explained here. Okay, so echo head tree representation. So I read about it somewhere else too, that you can basically call on some of those that were passed on. In this case, they are untyped. you can call tree representation, and this will like print out to the output basically like a representation of what the code looks like. So we have this infix, I guess, like a main node of the whole thing, and we have that it contains the identifier off, and identifier, I guess, off can contain two sub-elements, which is in this case animal on the left and root object on the right. Okay, so we have type name on the left and base class on the right. So that's how we can decipher it. So we can basically say that if it is actually that infix and the identifier is off, that means that the next object, because it was 0, 1 will be type name and the right will be name of the base. Okay. And if not, if it's still infix, but we have the star instead, oh, look at that. So you need to consider all the edge cases. So if we had type name with that was actually exposed, I presume that we're gonna get first identifier like this, and then we have identifier animal after that, and then we have some prefix with this and that. So I guess you will need to learn how NIM is formatting, taking in all those, how it's parsing the AST, the code into AST, abstract syntax tree, into AST, and therefore you need to account for all those possibilities. And this is already teaching us that the moment you mark something as an export, it changes up everything. And we have something like prefix, and I guess prefix means that if you have that whatever operator off, the first object passed to it will be the preceding object. Okay, that makes sense, and therefore we mark things a little bit differently. And we can mark something as, the whole thing as exported as true. And with else, we can just mark that there's an error, invalid node, and I guess print it out. Okay. The following points out the AST structure. Okay, import macros, dump tree. Oh, okay, the following prints out the AST. So, for example, we do import macros, dump tree, and we just pass it some kind of code. And this way we actually see what this code will compile to as an AST. And there you go. Statement list, type section, type definition. Okay, so type says, hey, this is a whole type section. And this part here is a type definition because you could have many of those. And then we have identifier X, empty. Okay, I guess can have some other stuff. And then it's a reference to, and we have object type. Again, something's empty and inherits Y, and then we have rec list. So I guess records, because all these will be records, and we have identifier definitions in there, which is Z of type int, and with empty default value, I presume. Okay, so in our macro, after we figured out what the type name is, what the base name is, and if it should be exported, after all that, we can create a new statement list for the result. So basically we get the new statement list, which should be what we receive from here as body, because up here, I guess after here, class, this was our head, and all this is our body. So I guess this will be a list of statements, right? Let's see. Statement list, create a type section and the result. So we have template, type declaration. So we're going again into templates that we haven't covered here yet. So this is a little bit overcomplicated example, I presume, for a macro, for a tutorial like that. Using so many things that weren't covered yet. And type declaration, AB is untyped again. I don't think I'm going to continue with that. Basically, we set up two templates for type declaration and public type declaration. Okay, so one will kind of return that, we'll be able to insert or extract code like type A is reference object of B. Okay, so this is actually proper NIM. We'll be able to just replace A with our type name and B with the type that we want to inherit from. And this is basically the same thing, just with the asterisks for exporting it. Young Akali says that there are a little bit nicer examples in the official tutorial. I agree. I tried to read through them a little bit, but I'd say they were a little bit discouraging in that official tutorial. Because before I started this whole series of learning NIM, I basically quickly read through all those 3 tutorials and those macros. I know at that point, they didn't explain a lot either, although I like that they explain templates before the macros, unlike here. But okay, we have those two templates. That makes sense. And basically, if it's exported, we just, to our result, we add get the AST for, and we have this type declaration public with those two. So we call this template. This should return code, I presume, and get AST. We will, again, ask the compiler to just get AST tree that we can just return there. And if it's not, we just call the same thing just with all the public. Okay. Echo tree representation of body. Exactly, a tree representation would represent our body, which in our case is the statement list. And we specify variable section and method definitions and another method definition. Okay, so I guess the statement list of various sections that were defined, okay, within our class macro. So we have this and whatever here. So basically whatever we find here or could find here, we need to cover in our macro, like those variables. Too bad that we can just take it by default, or we can just return them, right? So we have the section variables and we need to take care of those methods because they are important. So var declarations will be turned into object fields. So var reclist is new nym node and new node kind reclist. So that will be our new node. And constructor name, go specify new for it. And for the type, iterate over the statements, adding self to all the parameters of functions unless the function is a constructor. Okay, so that's where we iterate over them and modify. I'm not going through that code because when we learn the language a little bit more, it will make more sense, I presume. Right now, we're just scratching our heads like, okay, I guess language works like that. So, when we'll know a little bit more about the syntax and how it works in practice, what can end up somewhere, our brains will know a little bit more about all the edge cases and it will be easier to write some macro that actually, covers all the bases. Yeah, and then we have the echo result tree presentation. So this is what we will basically return. And wow, that's actually a really funny statement. So we know where to insert our list. And let's inspect the human readable version of the output, echo representation of the result. And it actually should print out the code that will be returned. That's very much like it. So, okay. And type, blah, blah. So that's good. And yeah, we can test it by writing all those things. And it should work. Very much like that there is a possibility of that. Because at some point I might be pissed off that I don't have some feature. And if I'm pissed off enough, I can say, screw it, I'm gonna write it myself without needing to, modify the nym itself and hoping that it's gonna be approved into the, into the repository or whatnot, or just operating on my own version of nym. That would be even worse. So hey, I like that there is that possibility. This is a little bit nicer because this actually changes a lot about the syntax of the language. So yeah, I like it. So that's it. We finished the whole nym by example tutorial. So I can actually close it.